Then next we have translations. What is translation? What do you mean by translations? What does it mean with the word translation? Yeah, obviously translate. But what does it mean with the translation?
Which we don't know anything. Translate.
Means from one form to another form kind of thing,
Sure.
right? Similarly, we in networking we have network address translation. Okay, means translating one IP address to another IP address. Now, why do we require translation? Why do we require the translation of IP addresses? Yes.
Public IP.
Both of
No one public IP addresses.
Mhm.
I can communicate with them.
We have limited public IPs.
Yes,
To communicate with the ISP.
to communicate with ISP. Okay, but that is the use of your public IP
To convert the private into public.
to convert private into public. Why do we require the private public concept?
Public IP address can be.
Because in internet the public IP only working.
If you remember, okay, if you guys remember, I have shown you this thing, why your NAT concept came up. Okay. Do you remember, I think our third or fourth class itself, when we were discussing about subnetting. Your public IP addresses are limited. Okay. Your IPv4 addresses are limited. So they came up with some solutions. One solution was your IPv6. Second solution was your CIDR, subnet. Third concept was your NAT. Do I need to show again? Oh, here it is. See, the internet community worked hard during the 1990s to solve this problem, coming up with several solutions, including the following. Okay, new version of IP, that is IPv6, assigning subset of public IP network, that is your CIDR, and network address translation, the NAT concept. Okay, so why they came up? Because the universe has run out of your public IPv4 address. The number of addresses in your IPv4 are limited. Okay, so NAT was designed so that okay, people can get some more time to shift to IPv6. Okay, but again, due to the benefits of NAT, people still use IPv4. Okay. Now translations. So here we'll discuss about network address translation. And in case of Cisco, we have two types of translation. Okay. One is the NAT. One is the PAT. Okay. Network address translation, port address translation. Okay. Then in the NAT, you have static and dynamic. Okay. Okay, let me static and dynamic. Then in PAT also static and dynamic. This is clear. This is with the Cisco. With other vendors, you'll come across two terms: source NAT, destination NAT. Okay, source NAT and destination. Okay, these are the two terms you'll come across with other vendors like If you go with other vendors like Juniper, Palo Alto, Checkpoint. Okay. So according to them, source net and destination net, SNet and DNet, in short. Now, according to a Cisco, we have your static net, dynamic net, and dynamic path. Okay. So these things will study. Now, whenever we are talking about translation, okay. So network address translation, okay. It's used to translate one IP address to another IP address. It is used to translate one IP address to another IP address. And mostly it is used to translate private to public or vice versa. Means private to public or public to private. Mostly it is used for this, but this doesn't mean you cannot translate public to public or private to private. Network address translation means translating one IP to another IP. That can be public or that can be private. But mostly we use it for translating private to public or public to private. Is that clear? Okay. Now let's go with the theoretical part. Okay. To access internet, one public IP address is needed. Because if you want to access the internet, see right now, if I show you my private IP, what is my private IP? 172.16.1.100, correct? But when I'm going to the internet, and on the internet, if I say what is my IP address? Okay, on the internet, if you go to Google and say what is my IP address, so my IP address is 106.51, 158, and 116. If you see 106, private or public? Public. Okay, so this is my public IP address. This is clear. So on the internet, when I'm going to the internet, I'm using what? A public IP address, and in my local area network, I'm using what? Private IP address. So how I'm able to communicate with the internet using this IP? So my router, my edge device, my router is translating my private IP to public IP. And when the response is coming to this public IP, and it is translating back to my private IP. Okay. So NAT is bidirectional. Okay. Private to public, and also the response public to private. This is clear. So the idea of NAT is to allow multiple devices to access the internet through a single public IP address. This is not basically NAT, but it will be known as PAT, port address translation. To achieve this, the translation of private IP address to public IP address is required. The network address translation is a process in which one or more local IP address is translated to one or more global. Means one or more private IP addresses are translated to one or more public IP addresses, and vice versa, in order to provide internet access to the local host. Then we have the PAT, port address translation, is a process where it does the translation of what? Port numbers. Okay, that is, mask the port number of the host with another port number in the packet that will be routed to the destination, and then it makes the corresponding entries of IP address and port number in the table. Now you're getting confused that what is it? Okay, see what will happen. Let's say, for example, consider a scenario. Let's say you have two PCs, PC1, PC2. Okay. And this is a server. Okay, let me connect the switch. Okay, let's say these are connected. This is your router. This is your PC1. And this is your PC2. And this is your switch. And let's say this is your Google server. Okay. So this side, let's say we are using the network 172.16.1.1.0/20. Okay. So let's say this is my PC having the IP .100. This is another PC having the IP .101. Okay. This is the router and this is Google. So works on HTTPS protocol. That means port number 443. Okay. And the IP address, let's say 11.100, just example. So here I have 172.16.1.1 on the LAN side. And on the WAN side, let's say I have the IP 11.1.1.1. Okay. Now what will happen whenever I try to access Google, my PC will generate a packet. In the packet, there will be certain entries. There will be information about source IP, destination IP, not the MAC address. Now we'll consider port numbers, source port and destination port. Okay. So source IP will be, let's say 1.100. Then destination IP is, let's say 11.100. Okay. And let me say this is 172.100. So that you can understand this is private and this is public. Source port, now see, whenever you are trying to communicate with the internet, your PC will randomly assign a port number. Okay. So this will be a random port number. And destination port, so to which port? I am trying to connect to HTTPS. My destination port will be 443. So this information will come to the router. Router will forward it where? To the Google. But before that, what it is going to do? It is going to translate. So let's say I have only one public IP on my router, and to this IP I'm translating. So my router will translate it to 11.1 and it will forward it to the Google. Correct? Now what Google will do? Okay, this one packet came from PC1. Similarly, when PC2 will generate the packet, what information will be there? Source IP, destination IP, source port, and destination port. Then again, this will be 172.101. This will be 11.100. This will be random, and destination port is 443. Okay. This packet will come to the router. Router have only one public IP. Router will translate it to 11.1 and it will forward it. Correct. Now server will reply. So when server will reply, source will become 11.100. Destination will be 11.1. Source port will become 443 and destination port will become random. Correct. Packet came to the router. Similarly, in this packet also, what will happen? Source IP will be 11.100. Destination will be 11.1. Source port will be 443. Destination port will be random. Correct? Packet came to the router. Now, if you see these both packets are the same, router will get confused. Should I send to 100 or 101? Okay. So for this reason, what they do, they are going to change the port number. Okay. How? Let's say when the request is coming. Okay. When the request is coming, let these responses come back here. When the request they are generating, let's say when this PC is generating the request, so source IP, destination IP, source port, and destination port. Source IP will be 172.100, destination IP 11.100. Source port this time, let's say 1234 is the port number. Okay, any random port number generated. Then destination is 443. Okay. So what your router will do? Your router will change the IP. This IP it will change it to 11.1, and this port number also, let's say it will change to, for example, 1111. Okay. Now what will happen when the response will come? Along with this, your router will also make an entry here that when the packet came from 172.100 and using the port number 1234, I translated it to 1 moment, guys. So it will make an entry that I translated it to 11.1 and port number, let's say, for example, 11. So when the reply will come, if the reply is coming to port number 11111, it will translate it back to this one. And it will make an entry, let's say, when the traffic came from 172.101, and let's say port number 2345, I translated it to 11.1, and let's say port number. So when the reply is coming to this port number and this IP, will forward it to 172.100. So here you see the IP is same, but the traffic will be segregated based on these port numbers. The IP, translated IP is the same, but the traffic will be segregated based on the port numbers. So this is your PAT concept, port address translation, translating port numbers. Is that clear? Okay. So that's why with the help of PAT only you are able to use internet using one single IP. So now if you see my public IP here, okay, this public IP. Now anyone who is connected on the third floor, they are using this same IP. Everyone using the same IP. Okay. And all the devices that are connected to the internet, every single device is having a public IP address. Even your phones, if you take out your phones and then type what is my IP address in the Google, you'll see your public IP addresses. Now, some of you will be getting maybe IPv4 addresses, and some of you might be getting IPv6 addresses, because right now the internet is shifting towards the IPv6. This is clear?
Excuse me.
Okay.
So when sending to Google.com, those back will happen. When you tell that,
No. That is not source and destination. See how they are saying source net and destination net. The translation of source is happening when you are going from inside to outside. Okay. So in source net, what will be there? Your static net, whatever static net you will study, that is the source net. Whatever dynamic net you will study, that is your source net. And also your dynamic PAT is. All these are form of source NAT. Okay, in case of other vendors, these are considered the source NAT. Okay. Destination NAT is when you go with the static path.
That is different.
Yeah, that you'll study in your
Firewalls.
firewalls. Yes, also known as port forwarding. Okay. In firewalls, you'll study. Destination NAT is what your static path. This is your destination. Okay.
We saw like static and static.
We didn't say anything yet. Okay, practicals I'll show you tomorrow only. Okay, because it will take some time.
Sir, can you please repeat both the data and I don't understand.
You didn't understand. See, whenever you are sending a traffic, obviously, if you saw the TCP header, there was a source port and destination port. Okay, so whenever your PC is generating the traffic, let's say here it will generate source IP, destination IP. First of all, let me do one thing. Okay. Let's say on the router you have configured port address translation. Okay. So you have configured a rule. What rule you have configured? NAT rule. And that NAT rule says if anyone is coming from 172.16.1.0/24 network, okay, just translate them to the IP 11.1.1.1. You gave this rule in the router. You configured this rule. Done. Okay. You have configured this rule. Now what your router will do? Your router will start doing the translation. So if it is not doing the port translation, then you saw what is the problem. When the reply is coming, they will have the same IP. For example, when this is sending the reply, so the reply will be sent from 172.16. Okay, let me generate the packets. Who will be the source? 172.16. Who will be the destination? 11.100. Correct. Source port will be, let's say, okay, 1234. Okay. And then destination port will be 443. Packet will come here. According to this translation, did I say translate port numbers also? No, right? So what will happen? It will translate to, source. Will translate to 11.1. Send it here. Now this PC will reply. Then when it will reply, it is going to say that, okay, source is 11.100, destination is 11.1, source port number will be 443, and destination will be, let's say, your port number 1234. Okay. Packet will come here. Similarly, this will send packet. Reply will come. So everywhere, if you see the destination IP 11.1, and here will also be 11.1 only, and router will get confused now. That what to do? Because if your router makes an entry that, let's say, 172.100, I translate to 11.1. Then 172.101, I translate to 11.1. Now, when it will see, okay, here also 11.1, and when from here it is coming, also 11.1. So where should I send the packet? Because both IPs are getting translated to 11.1 only. So that's why your router is going to start segregating the traffic based on the port numbers. Means instead of making only IP address entries, it will start making the entries with the port numbers. That, okay, the packet came with 172.100 and with the source port number 1234. And what I'll do, I'll translate it to, let's say, 11.1, and let me keep the same port number also, no problem. Okay. Then let's say 172.100, 101. And the port number, let's say it is coming with 2345. So this one I'm translating to 11.1 and port number, let's say 23451. Now, when the reply will come, it will also start checking the port number. So if the reply is coming for 11.1 and port number 1234, now check the entry. It will come to know that, okay, I have to forward it to 172.100 port number 1234. So like this, it will segregate the traffic based on the port numbers. This is your PAT concept. This is clear. But why do we require PAT? Right? Not to maintain same session, but to use multiple systems, internet in multiple systems using one single IP address. Okay, with static NAT we cannot use, with dynamic NAT we cannot use. Okay. What is static NAT? Static NAT, see. Okay, let me tell you in short, then we will study. No. Through PAT you can go. Yes. Now, what is static NAT? In case of static NAT, it is manual mapping, first of all. Okay. Manual mapping means you will manually define the rule that, okay, this particular IP address. Okay, or let me say manual mapping, a private IP address to a public IP address. Means fixed. Okay, this is fixed mapping. Okay, so if it is fixed mapping, if I have n number of hosts, how many public IPs I will need? Right, n number I will need. So the number of public IP required will be equal to number of hosts that want to use internet. Okay. Is that clear? That many public IPs you will need here in case of static. This is clear. So this is also known as 1-to-1 mapping. 1-to-1 mapping means one private IP address is mapped with one public IP address. So if you have 3,000 computers in your company, you will need how many IPs? 3,000 IPs. So this is not a good solution for enterprises. Okay. Then where do we use? So your static NAT is used for systems that accept incoming requests. Like your servers, whenever you want to access the servers. So servers should have a fixed public IP so that we can access them anytime, anywhere. Okay. Example, servers. So if your companies are having servers, in that case, you will need a fixed public IP. Because every time, let's say today, Google IP is something else. Okay. And tomorrow, if I type google.com, my DNS cache is giving me the same IP and I'm getting redirected to Facebook. Not a good idea. So for your servers, you should have a fixed static IP. Okay. So this is where we use static NAT for the servers. Is that clear?
Number of public IP required is equal to number of private.
Yeah, not IP range, but again, let's say in your private IP range, there are systems that do not require internet connection. So we cannot say that, okay, every system is going to require, but anyone who want to communicate with the internet, they will obviously need. Okay, means there can be, let's say you have printers, network printers. So they are also having a private IPs and all. So for them, we do not require static NAT. Correct.
Okay. In private network that won't be used.
Exactly. Okay. Now here, what is the problem? You have to manually define if there are 1,000 systems in your company and if you have purchased also 1,000 IPs, first of all, then you have to map each and every IP with each and every public IP manually, one by one. Okay. So to avoid this scenario, next concept came up, your dynamic NAT. Okay. Dynamic NAT. Now again, dynamic NAT is exactly similar to your static NAT. Dynamic NAT is exactly similar to your static NAT. Only one difference, automatic mapping. Here we do not need your one to means here we do not need manual mapping. Okay. So here you'll see kind of you can say mapping is done automatically. Okay. So here for public IP addresses, we will have a pool of public IP address. Pool means a range. Okay. A pool of public IP address is used in dynamic NAT. Okay. So what will happen? The private network will be mapped with the pool of public IP address. Is that clear? Now the mapping is happening automatically, but still this is one-to-one mapping. One private IP address will be mapped with one public IP address only. Okay. One private address will be mapped with one public IP address. This is clear. So here also one-to-one mapping is there. Means if you have n number of hosts, here also you can see same thing. The number of hosts or the number of public IP address required equals to number of hosts that want to use the internet. This is clear. So if there are no sufficient IPs in the pool, let's say you have 10 IPs in the pool and you have 11 systems. Okay, then your system number 11 will not be able to use the internet. Okay, the packets will be dropped. So either the system number 11 has to wait for an IP to get free, or its packets will be dropped. Okay. So if there is no free IP in the pool, the packets from next system, next host will be dropped. Simple. That system will not be able to communicate. Is that clear? Then we came up with the concept of PAT, port address translation. Okay. So in case of PAT, multiple private IP addresses are mapped to a single public IP address. Mapping is done automatically. Okay, we don't have to map each and every IP with the same. And the traffic is segregated based on the port numbers. The traffic is segregated based on the port numbers. This is the introduction to your NAT and PAT, static NAT, dynamic NAT and PAT. Okay. Now see, static NAT. In this, a single private IP address is mapped with a public IP address, that is one-to-one mapping. Okay. This is generally used for web hosting. These are not used in the organization there, as there are many devices that will need internet access, and to provide internet access, a public IP will be needed. So suppose if there are 3,000 devices that need to access the internet, the organization has to buy 3,000 public IP addresses. That will be very costly. Okay. Then we came up with the dynamic NAT, because manual mapping you had to do there. in this type of NAT, private IP address is translated to a registered or public IP address from a pool of public IP address. You will use a pool. So if the IP address of a pool is not free, then the packet will be dropped, as only a fixed number of private IP address can be translated to public addresses. So if in your pool you have 10 IP addresses, only 10 systems can use the internet. So suppose if there is a pool of 2 public IP address, then only 2 private IP can be translated at a given time. Okay. If the third private IP address want to access the internet, then the packet will be dropped. Therefore, many private IP addresses are mapped to a pool of public IP addresses. So your dynamic NAT is used where the number of users who want to access the internet is fixed. If you have 2, 3, you can use it. This is also very costly, as the organization has to buy many global IP addresses to make a pool. Now, to create a pool, you have to purchase multiple IP addresses. Okay. Then finally, we came up with the concept of PAT, port address translation. So in this, many private IP address can be translated to a single IP address. Now, how many? Approx 65,000. In case of PAT, with the help of one public IP address, you can use approx 65,000. Means you can map 65,000 private IP addresses to a single public IP address, because depending on the port numbers. So port numbers are used to distinguish the traffic, which traffic belongs to which IP address. And this is most frequently used as it is cost effective, and thousands of users can be connected to the internet by using only one public IP address. Okay. So this is small introduction to your translation. And
Sir,
yes.
In case of servers, Google servers,
Mhm.
you are using NAT concept.
Mhm.
But Google has so many servers.
Mhm.
So they are different public IP addresses.
Hmm?
Google has so many servers. For each server, they have different public IP address.
What is Anycast? What is Anycast? Shared address. Multiple nodes in the network use the same IP address, and the traffic is delivered to the already clear. Correct? Now understood?
It's understand, but the servers have same public IP address or different public IP address.
See, all the servers, they are put up in a data center. Servers are available. Let's say if Google is available in India, right? So let's say they have a server in Bangalore, for example. Now, whenever we'll try to access Google, I'll say google.com only. Means my DNS will resolve to that particular IP address only. But I will be connected to Indian server. Okay. Same way, if anyone else is connecting, the DNS will give them their IP, and then they will be able to connect. Okay. This is clear. Okay. Now see, whenever you are using NAT, okay, using NAT, if I'm going on the internet, so I will be using what? Public IP only. Do anyone on the internet will come to know about my private IP? No, because my private IP is not even traveling on the internet. So this is one more security feature, you can say, that even if the Google servers are using, let's say, for example, private IPs in their local network, still the public IP is safe. So we will never come to know that, okay, what is the actual public IP? Is that clear? Okay.